to memory. But if you can get all that down, you're basically done, okay? Because of symmetries, all right? So we're gonna move to quadrant 3, okay, quadrant 3 here, and you're moving directly across from like this 30. So this 30 to this one over here is 210. And then similarly with the 45, that's 225. And then with the 60, it's 240. The
Okay.
ordered pairs are, you know, again, you just follow that line all the way across there. They're just the negatives of those. So that's negative square root of 3 over 2, comma, negative 1/2, negative square root of 2 over 2, negative square root of 2 over 2, negative 1/2, comma, negative square root of 3 over 2. And that takes care of that. Any questions on what we've done so far?
At the moment, no.
Okay, do you feel like you could reproduce this?
Probably yes.
Okay, so now we're going to move to quadrant 2. The thing about quadrant 2 is, like, I want you to focus on, and I'm going to switch colors here just because I think it'll maybe help here, is if you look at this point right here, they have the same y value.
Mm-hmm.
So that's like kind of your way of sort of figuring out what we're the same height. So that means it's square root of 3 over 2. But to get there, you're going left. And we know that in quadrant 2, the x values are negative, the y values are positive. That's just how they get there. And so it's negative 1/2. I try not to think of it in terms of like, oh, you know, x is negative, y is positive. I look at sort of these symmetries of like, okay, I'm going straight across there to get to that one. Similarly for the 45 here, you know, we're moving sort of straight across here. The y
Mm-hmm.
value is the same, square root of 2 over 2, but the x value is negative, like that. And then similarly here, this one here, we get to that one is, excuse me, negative square root of 3 over 2, comma, 1/2, like that. Now, in terms of the angles, that's a little bit harder, but you can see here that this angle right here is the same as this angle right here. So if you can remember that this is 30, to get to 60, this is another 30, so that's 120. That's one way to do it.
Okay.
To get to the next one here, you probably notice that there's this increment. It goes 15 and then another 15 each time. That down here at like 210, it's another 15, it's another 15. So the 120, you go another 15, that's 135, another 15, 150. So in some ways, this is, you know, this one's tough because you gotta remember a bit more. But if you can get quadrant 2, just like if you can get quadrant 1, you can get quadrant 4 pretty quickly.
Okay.
And the reason you get quadrant 4 pretty quickly is by the same symmetries that we used, you know, following these lines from 1 to 3. So this one up here at 120, we go down here, adding 180, that's 300 degrees.
Mm-hmm.
Okay, and then similarly for the 135, or you can say, well, they go up by 15 each time, 315, 330. To get the ordered pairs, you can use, you know, you can use like some of these points here, or you can use the ones from the first quadrant. If you use the ones from the first quadrant to drop them down, you can see that they share the same x value, but the y value is negated. So again, it's like, what's the best way to do it? I'm not sure. They have the same x value, but the y value is negated. If you look from the 120 down here, you can see it's the same x and y's, they're just negated. So remember how we negated both of these in quadrant 1 to get to quadrant 3?
Mm-hmm.
You can also use the same approach here from 2 to 4 as you negate both of them.
Okay.
So this one at 135 to 315, you negate both of them. So it becomes positive square root of 2 over 2, comma negative square root of 2 over 2, like that.
Mm-hmm.
Sorry, my technology just stopped working here.
You're good.
Something has happened. Okay, well, that's bad. just curious, what do you see on my screen right now, if
I
anything?
see it. It's just like super light.
Okay, let me stop sharing here. That's probably what had a computer crash before we started here. So let me see if I can get this resolved quickly. Screen. Always something going on. There's never just a
I know.
simple thing here. So yeah, so we
There
got
we go.
like I said, you negate this point right here. So it's square root of 2 over 2 comma minus square root of 2 over 2. And then this one, similarly, you're going to negate. So it's square root of 3 over 2 comma negative 1/2. Or if you prefer, you can go from quadrant 1, kind of dropping down, straight down on that. All right. It's really important to get this, like, you can't overemphasize how important this is, like, especially you got a quiz on it and other things. Now, like, getting this isn't like, you don't get like, it's not like you're gonna get 100% of your quiz just because you got this down, but you can't do your quiz without having this down. So it's like, you got to do this anyway. We missed doing the radian angle
Yes.
in here. So that's kind of like, what are we going to do for that? I almost need to start a new one just to kind of, talk through that a little bit
Okay.
here. There's just not enough room on, and I write big anyway. So in terms of your angles now in radian, I know students don't love radian, it's just the way, way it is. So this is 0 and 2 pi right here at the start. Pi over 2, maybe those are familiar for 90 and 3 pi over 2. But it's the other ones here that I think are really tough. It's like, how am I supposed to remember that this is pi over 6, pi over 4, and pi over 3? I don't have a good answer for you. Really don't. Like, you could sit here and convert every one of these, like this first one is 30 degrees multiplied by pi over 180 to get 30 pi over 180, which is pi over 6. You could do that for every one. I'm not sure that's gonna be enough time to do all that. But that would be how you would do it for these ones if you don't know them. Like, if you had the degree, you could, convert. Now, in terms of like going across from say, let me grab a different color here. So let's say we're going from like this one down here, pi over 6, to this one over here on the lower left. It's pi over 6 plus 2 pi, I'm sorry, plus pi, because pi is 180. Okay, so then you're making a common denominator here. Pi over 6 plus 6 pi over 6 is 7 pi over 6. So that's where I'm not sure how to best help you, because at some point there is like a, you got to decide what you're going to do to make this work.
Okay. So the pi over 2 just starts at the top.
It's 90 degrees. Like, you can
90
get,
degrees.
like, I guess what I would tell you to do, if you're asking, is to use all the degree measures and convert them to radian by multiplying by pi over 180.
Okay.
But that's kind of slow, but it can be done. Then I would take care of some symmetries here, like the fact that you can add pi to get these on the left. So that like pi over, if you take pi over 4 and you add pi to it, it's like adding 4 pi over 4. So it's 5 pi over 4. I don't know how comfortable you are with that, but that would be how you would go to this other one.
Okay.
I don't know, does any of that kind of stand out to you, or any of that?
Yeah, I think the multiplying thing will definitely help for sure.
Okay. So this is piece one. Piece one is like, yeah, I got my unit circle down. We spent 15 minutes. I mean, I've been talking on it. Believe me, if you were to practice like once after the lesson, once later today, once in the morning, you probably could do it in under 10 minutes. And
Okay.
eventually you can do it under, 5 minutes if you need to. But you can look at it, start writing it. You can print blank unit circles. Whatever you need to do that. Now, the next thing for us today is to use the unit circle. So let's assume you've got it.
Here, let me just copy the math really quick.
Sure. And also, again, I'll drop in the chat here the link to the reference sheet that I really like. And we'll start using it for the next part of the lesson here.
Okay, all right.
You all caught up?
Yes.
Okay. So that link I sent you on page 3 has this, and we're going to use this for here for the rest of the time here to work on some problems. So I'll put it up on other problems, but what I want you to do though is keep in mind that it's so much easier when you have this, like, but I'm not going to give you just direct problems, and direct problems are like, what is the sine of 3 pi over 4? We'll start with 1 or 2, but that's not the kind of problems you're going to get typically on a quiz.
Normally, yeah, I think that's the kind of thing that's like on my unit circle quiz. So
Oh, it is. Okay.
yeah.
So then it is very important that you have this down. But for now, and I'll increase the difficulty as we go. If you recall from yesterday, the x coordinate is the cosine value and the y coordinate is the sine value. So once
Okay.
you have these ordered pairs around the edge, if I ask you the sine of 3 pi over 4, you simply go to 3 pi over 4 and grab the y value.
Okay. So sine 3 pi over 4. So that would be square root of 2 over 2.
Yes, very good. Okay. Now here's where I make this more difficult. I'll do something like this: cosine of minus 90 degrees. Okay, so you might think, well, geez, I've never seen that before. How can I do it? It's tough. All the unit circle involves you going this direction, which is counterclockwise, CCW.
Mm-hmm.
And if someone came up with that, I don't know, this is the way it goes. Minus 90 means you're going the other direction. It means you're
So
going
it would be the 270.
exactly. And you have to be comfortable with that. You could change it. You could say, okay, it's really the cosine of 270. That's fine.
So then that would be 0. Or yeah.
It would be 0. Okay, very good. All right, so let me grab this unit circle here again, bring it down. We'll do some more problems here. All right, so another type of problem I could ask you is the sine of 480 degrees. And again, you'll notice that this is not on your unit circle. This is, just, so what you have to also know is that when you go all the way around, it's 360. So what you can do with this number is you can subtract it from, just kind of like you did before, you can subtract 360 from it. This is really the sine of 120. Have you seen that?
Yeah.
Have you seen that before? Or is that completely new?
That makes sense though.
Okay. So what would that be? What would the y value be there?
So that would be square root of 3 over 2.
Yes. All right. So that's your sine or your cosine. Okay. The tangent is kind of the first one where you've got some issues because you can't just directly look it up.
Yeah.
So it like even though you're given the unit circle or you're going to calculate it, write it down, you're going to have to do some work. And I don't know what to say. It's just like there's so much to remember here. That's the hardest part of this. It's not necessarily any one piece that's difficult. It's piecing it all together. So you have to remember this is sine over cosine. It's y over x. What would that be here? What's the y value? What's the x value?
So it's sine over cosine, which is 1 over x, which is negative 1/2 over negative square root of 3 over 2.
Yes. And this is correct, but you can't leave it like this if you want, full
Mhm.
credit. Or if it were multiple choice, you wouldn't see this answer. This would just wouldn't be there. Do you remember from yesterday how to simplify something like this?
Yeah, so the twos are both on the bottom, so they just cancel out,
Okay,
which leaves you with 1/√3, but then you have to rationalize the
yes,
denominator.
good.
So that means that it is just square root of 3 or it's just 1, or no, square root of 3/3.
Yes. Very good. Okay, so let me show that here. So square root of 3/3. Yes, good. All right, now really quickly here on page 2 of that reference sheet that I sent you, there are the tangent and cotangent identities. So tangent is sine over cosine. We've used that. I presume you've heard cotangent before, cosine
Yes,
over sine. Okay,
yes.
and then
Cosecant
cosecant,
also, yeah,
secant, cotangent, sine, cosine.
yes.
So like that's where this gets even harder is I'm going to give you some problems now where it's going to be not just, sine, cosine or tangent, it's these other ones. And that's really where
Mhm.
this kind of, most students just, they really struggle because it's just so much to remember. We'll start out not too bad here. How about the secant of pi over 3? Okay. And do you have a unit circle up, or do you want me to keep snipping it in for these problems here?
If you could just snip it in, that'd be helpful.
Sounds good. All right. I'm gonna just resize this just a tiny bit so we can see it. All right. Yeah, that should work. All right.
Okay. So the secant is 1 over the cosine. Okay, so if it says, okay, I got 1/1/2.
Okay.
So how would I simplify that when there's not two of the same denominator?
Right. So you multiply the top and bottom by the reciprocal.
Okay, reciprocal.
On the top, you can treat it as 1/1. Okay. And then your bottoms all cancel out.
So then it's just 2.
Yes.
Okay.
Let's try another one here. Let's try the cosecant of 5 pi over 4.
Okay. I got -2/√2.
Okay.
And then you have to rationalize that
Yes.
also,
Yes.
right? So then that is -2√2/2,
Okay. What does that become?
which is the same thing as -4.
So here's what I heard. This is correct. The twos on the outside cancel.
They just cancel out, so
Yes.
-√2.
Yes. Good. Very good. All right. Let's do another one here. Let's go back to secant. All right, let's go secant minus pi over 6.
Okay.
I'm just gonna step away for 30 seconds to grab some coffee. I'll be right back.
Okay.
Oh, how are you doing on this one?
Good. I think I got it. Let me just make sure. I got, okay, wait. I have to rationalize it. Okay. Okay, I got 2√3/3.
Good. Okay. So what you may feel like right now, because we've gotten 3 different answers, we've gotten 2, I shouldn't even write. We've gotten 2, we've gotten minus √2 or √2, 2√3/3. You might feel like, wow, there's a lot of possibilities. There's actually only, I think, like 10 or 11 that you can get. So we're coming up on like having you seen all the possible answers. And I can
Okay.
make a list here at the end, but what I don't want you to feel is like, how am I ever going to know this on the exam or quiz because there's so many? There's actually not. There's only a couple, 10, 11. I mean, it seems like a lot, but it's not as bad as it might first appear. Now we're going to
So
move. Good.
for just making sure I solved that one right for the negative pi/6, I just looked at pi/6, which is 30 degrees, and then I went into quadrant 2 on the opposite side, which was 11 pi/6, and I used those coordinates. Is that correct?
Yes, that's correct.
Okay.
I would someday prefer you to just go down straight down, but yeah, I'll take that way of doing it.
Mhm.
So, okay.
That's pretty much what I did because you said it went counterclockwise normally. So when it's
Yeah.
negative, it goes the opposite way.
All right. So cotangent now, we'll do cotangent of, which one have we not done yet? We've not done, let's do 2 pi over 3. Okay. So this is where you got to remember, I'm sorry, we have done this one. Let's not do that.
Okay.
Let's do cotangent of minus 5 pi over 6. So like you just mentioned here, you can go to 5 pi over 6, but you got to switch quadrants and or you're like, okay, it's down here. It's the cotangent is cosine over sine. So you can write that if you want. It's not necessary, but you can do that.
Cotangent is cosine over sine.
Yes. Yeah. So just to go back here, you'll want to get all these, like they say unit circle quiz, but it's really unit circle plus these identities plus,
Yes.
positive and negatives, and it's
Yes.
not
So it's
really
just like everything.
yeah, it's everything. The everything quiz. Okay. Cosine here is minus square root of 3 over 2 over negative 1/2. These have the same bottoms.
Mm-hmm.
The negatives cancel.
So then it's just √3.
Yes.
Okay, perfect.
All right. So let me give you a few more here. So let me make these a little more difficult, maybe. We'll see here. Let's go back to I don't know. I guess I could do other things. Like I could say, like, what is 1 over the cosecant of minus 300 degrees?
Okay.
How's this going?
Good, I think. Let me just make sure I got it. Okay, so without it being rationalized, I got 3/2√3.
3/2√3. Okay. The thing that initially comes to mind, and I believe this is correct, is my guess is you did not use the fact that cosecant is really sine. Whatever cosecant is really sine, which would
Oh, it
save
is?
you, it would save you just a tiny bit of time here. Because when you rationalize this, I think you do get the right result here. But let's just do it. Let me just show you it this way. The reason that works is, again, it's one of those reciprocal identities up here. 1/, cosecant of sine. It becomes harder and harder to find ways to make these difficult because you just have to sort of be deceptive here. But these are worth remembering for that purpose. So sine of -300 degrees is right up here.
So it would just be √3/2.
But yeah, but let's just see. I mean, I think yours is correct here. So let's go square root of 3, square root of 3. So on the bottom there, you get the top is 3/3, but on the bottom it's 2 times 3. Those 3 cancel. Square root of 3/2.
So it does work, but that's just easier.
Yes, it's all about, figuring out what's going to be best for you when you're doing this. Okay, let's look at some more problems here. And all right, so let's talk about some exceptions. Everyone loves exceptions, right?
Mhm.
Yeah, math's great until you get some exceptions. So first one is not an exception. What is the tangent of 0? Tangent of 0 is y/x, 0/1. This is 0. This is okay. Division is a sharing problem. It's okay to have nothing to share. Okay. This is not an exception, but tangent of 90 degrees is, it's y/x. That's 1/0. This is undefined. So anytime you have a 0 on the bottom, it is undefined.
So 0 in denominator.
Yep.
Means it's undefined. And then you could theoretically, if you didn't know the tangent of 90 degrees on the top of off the top of your head, you could figure it out with the sine over cosine
Yes.
or
yes.
whatever x.
y/x. Yeah, you'll so what I don't want you to do is, and this is when I say that, I mean, like, it's best for your learning, is I don't want you to try to learn like it's y/x or it's x/y or it's something else. Like, try to eventually get to that, but
Memorize the cosecant and all the
yeah,
cosine and sine first.
yeah, it's case specific. It's like, because if I give you something like this, secant of minus pi, I want you to think of this as 1 cosine minus pi, not 1/x.
Okay.
That's my preference. You may not like it. You get to decide. But could you go ahead and evaluate this for me, please?
Yes. Okay. Secant of negative pi is the same thing as the secant of same thing as the secant of, would that be the same thing as the secant of 2 pi?
It's minus pi
Or
is, yeah, minus pi is on the unit circle. It's okay.
Oh, it is? Okay.
Well, it kind of is. It violates that whole, like, well, I'll just go to the pi and then go to the other side because it's right on the line. It's right there. That's both pi and minus pi.
Okay. Okay.
So it's like, what is the x value at that place?
-1. Okay, so that would be 1/-1.
Is that okay?
-1. I mean, I don't see a 0 on the bottom.
Yep, that's fine. So yeah, I can't just give you all exceptions in here. I mean, that's not very helpful, but you have to remember that like sometimes you got to be careful. What if you thought it was 0 and it's 1/0? No, it's the x value. Let's do another one here. Let's do cotangent of minus pi over 2. Go ahead and try that one, please.
Okay. Okay, I got 0/-1.
So cotangent is cosine over sine. 0/-1 is correct. Is that, what is that? Does that become?
That just becomes 0.
Is 0. Okay.
Okay.
All right. So the only in it just be very careful here because it's easy to flip them, right? And you're like, ah, is it
And
undefined or not?
if it comes out to 0, it's okay, but
That's okay.
there's
Yeah,
the 0 on the denominator, then it's undefined.
that's right. That's right. And I mean, you'll probably get like 1 on your quiz that's undefined.
Okay.
And it'll come from, one of these here. So let me give you, let's do a few more here. Let's just have you do like the tangent of 5 pi over 4. Come up with a couple for you to try here. The cosecant of and here's a good one to look at. All right, so here's a couple problems for you to try. If you have some questions, please ask, but kind of at the point in the lesson where you got to try a few and just see if you have any questions along the way.
Yeah.
And if you want me to check any along the way, I'll be happy to do that.
Okay. Okay, so for the first one, I got 1,
Good,
and then for the second one, I got undefined.
good.
And then also for the third one, I got undefined.
How did you deal with the 9 pi/6?
I simplified it to 3 pi over 2.
Good, very good. Okay,
That confused me for a minute. I was like,
yeah.
wait.
Well, and so what I'm doing here, this is, but I told this to your mom, I said, I think Maya's, she's pretty good math student. She just needs a little assistance here. Like I'm searching for problems to like challenge you right now. There's not much left in terms of like this. So I guess my question or thought for you is like, what is your plan to learn the unit circle between now and tomorrow?
So I think what I'm really gonna do is like almost, I guess, like layer it. So like first learn like where each of the degrees are, and then add on where each of the radians go and the coordinates as well for each separate quadrant. And then with that, I'll put in the equations as well with like the tangent and all of that stuff is what I think I'm gonna do. Cause I have some extra resources too, like my teacher has given me like flashcards with like each one so I can like check my answer for like cosecant and that kind of stuff.
Good, good. I like all that. I sent you over a link for a blank unit circle.
Okay.
I recommend trying to fill it out, but here, one of the things with memory, the way it works is you don't want to reinforce the wrong answers.
Mm-hmm.
So it's better to like incrementally do it, keep checking, looking at the correct unit circle. You don't want to remember it wrong because then you'll remember it wrong forever. That's bad.
Yeah.
So, but I'll just reemphasize that one of the reasons you were so successful doing the unit circle problems is because you had this down. If you don't have this down, you can't do any of these. And you
Mhm.
did really well once you had it down. So just keep that in mind. We do unfortunately have to stop here. I've just got a really hectic schedule today.